Hey there and welcome to the Code Wrinkles channel for this brand new video, and in this one we'll talk about the dependency inversion principle, so the last principle from the solid or object-oriented design principles. We have already covered all the other solid principles in previous videos that you can check out on this channel, but I have left this video for a longer time because I think that there are some big problems when it comes to understanding this dependency inversion principle. And believe me, recently I have done a lot of technical interviews, and most of the people, even senior engineers, struggle to exactly understand and explain clearly what all this dependency inversion principle is all about. And virtually everybody actually takes this principle for dependency injection, which we will see they are total different things. They are related. I don't say that there isn't any relation, but they are two different things. And in order to actually understand how they are two different things, we have to understand the dependency inversion principle first, to then understand what exactly dependency injection means. Now, the reason why there is, in my opinion, a lot of confusion when it comes to this principle is that when we look online for articles or tutorials or videos where this principle is explained, I think that they are using some examples that are actually not relatable. For instance, virtually all of them are giving some examples like a business logic class and a data access logic class, and then the data access logic class is referenced or used directly in the business logic class, and everything actually packed together in one single project, one single solution. And that's not relatable because in our day-to-day practice, we are, however, very accustomed to have those classes in different layers, in different projects. And nowadays, of course, we are used to use dependency injection everywhere. So really, it is very difficult to kind of like understand, why do I actually need to care about this if everything is taken care of? And in this video, we'll try to understand and make the explanation of this principle as easy as possible. And to do this, we will actually focus on only one single question that we want to answer during this video. And the question is, what are we inverting? So please keep this question in mind as we'll progress to this video. You will see that step by step, you'll see, or you'll find one more explanation or one more step in the direction of finding the answer of what we are actually inverting, and then we'll explain and understand what everything is all about. But let's start from the definition, because the definition says higher level module should not depend on lower level module. Both should depend on abstractions. And in fact, there is actually a continuation to it, which a lot of people tend to miss. And the continuation says that everybody, both the higher level modules and the lower level modules, should depend on abstractions, not on details. Okay, so I guess there is really a lot of stuff to take in, and I would suggest we will take it step by step. So first of all, the question is, what is a high level module and what is a lower level module? And the explanation to this is actually very simple, even though there is a caveat also to this point. So let's start by analyzing what we have here. So we have here a very well, simple solution, but I think it's very easy to understand how things work here. So we have here an app. It's a console application. It doesn't really matter what the application does, but what it matters is that this is our program class. So what we have here is, okay, we instantiate a new logger manager. We want to use some formatters for that, like the default formatter or exception formatter. And then we want to actually log some messages. Like, for instance, we want to log a message and maybe we want to log an exception or things similar to that. Now, where does all this magic come from? Of course, this magic comes from the other project that we have here, which is our CWK logger, a very simple logging library that's designed to kind of like just log messages to the console, maybe format them a little bit to have a nice and neat look. And that's mostly all about this. So basically I have here a library, and if we look in this, we'll have here this logger manager, which exposes these methods like log message and once again log message, but with the exception formatter. Now we have targets. Right now we have only one logging target, which is the console, but potentially we can extend the functionality of our logging library to also support other targets like logging to files or similar to that. And then we have those formatters like default log formatter and the exception log formatter that kind of like they format the messages a little bit differently. Now we can see that, okay, this class program uses actually the constructors of these classes that we have in the library to create new instances. Now, when we think about a higher level module, you can think about it as being a class or as being a method that kind of like uses a new constructor, or that it constructs a new object. Like we say here, logger, new logger manager, or default logger formatter, or exception logger formatter. So it means that actually the class that actually news up some instances of some other classes, they kind of like are the higher level module. But then again, if the class would also have properties, for instance, of type logger manager, so a different class, that would also mean that this program class is a higher level module. So if we put things into perspective, we have this program class, which is the higher level module, and we have this logger manager class, which is the lower level module. So if we take a look here in this logger manager class, and if we apply here exactly the same principle, so if we see a constructor, if we see an object instantiation, if we see a private field of a custom type, if we see a property of a custom type, that kind of like already gives us a signal that, hey, this is a higher level module. So the logger manager, we see that it uses this console logger as a private field. So we use the console logger here as a variable or as a data type, which means that, yeah, of course, it means that the logger manager is a higher level module in its turn for the console logger. Now, also this logger manager uses this default log formatter and exception log formatter. Now, if we go here in the console logger, we see that actually this doesn't really depend on anything else. It doesn't new up any other object. It kind of like doesn't have a field of any other custom type. It doesn't have a property of any custom type. So it's just a method. It's just on itself. So this is really the lowest level module. Cool. So we can say as a summary that, hey, we have this program class, which is a higher level module, for the logger manager class, which in turn is a lower level module for the program class, but is a higher level module for the console logger and for the default log formatter and the exception log formatter. And of course, if we take a look at this could pose a lot of problems, because for instance, if we change something here in this logger manager, like we use the constructor, if we say here, for instance, say I want to provide me a console logger. Let's use the console logger logger in the constructor and then assign it here to this field. Well, then of course we see that everything breaks. So whenever we do a change, even the smallest change to some of the lower level modules, they could break everything in the higher level modules. So this is of course a big problem, and this is already a sign that hey, we might have a problem with the dependency inversion because things are too tightly coupled together. However, before we go into refactoring this code and understanding exactly what this dependency inversion actually means, I want to also go into one point that's very important and that I have seen to be actually explained or showcased in a wrong way in a lot of different articles that I came across reading the past few weeks. So the thing is that, okay, we said that whenever we have a property of a custom type or a private field of a custom type or a constructor when we are instantiating an object, then the class in which we are currently becomes a higher level module or is a higher level module, and it kind of like depends on the lower level module. And of course we will say, okay, we want to decouple this. So yeah, we want to abstract everything away because as the definition say, everything should actually be based on rely on abstractions. So I want to show you because some people then have read such articles or have watched the videos. And recently when we had an internship program and I have one of my interns coming up with a new application because they needed to build an application, and with the initial model for the application, with the initial domain model, and it was actually something like this. So we have this employee class, we have this address class, and obviously the employee would have here an address, so a property of type address. But then I saw that basically all such properties of a custom type in the domain model were abstracted through interfaces. Like we have it here. We have here this iAddress interface, and the employee actually has the property of type iAddress. And I asked him, okay, but why did you do this? And he said me, okay, it's because the dependency inversion. So we don't need to actually couple things together. So this is actually where another nuance of what dependency inversion and coupling actually means, because there are situations and situations. Now, if we take a look carefully at what we have here in this program class, we see that here we have this program class that kind of like does something, whatever, but in doing so, it actually heavily depends on things that are totally not related to the class itself, like the logger manager, the default log formatter, the exception log formatter. So basically this program class, although it doesn't really have anything to do with logging, it just wants to log messages, it needs to know, or it knows a lot of stuff about things that are totally not related. And in this case, we say that, okay, we have a tight coupling, and this is also a sign here that we are violating, or that this doesn't follow the dependency inversion principle. But on the other hand, when we come to our employee, this is a totally different story, because what we do in our domain model, we usually want to model real-world objects in a way that computers can understand. And if we have an employee, well, an employee, he or she has an address. It's a clear address. It's not an address. It's not an I address. If the employee changes the address, then we just change the values for the street, for the number, whatever is needed. But the employee kind of like, it needs an address. And here is where another very important concept comes in, which mostly everybody seems to forget, is cohesion. Like we talk a lot about coupling, and we have this obsession to decouple things, but we don't think about cohesion anymore. And cohesion is actually, well, a principle that kind of like in a summary says that we need to have all the data and all the behavior that kind of like belong together in a single place. Now, of course, in this case, the data, the address, it belongs to this concept of employee. It has an address. So we cannot just simply abstract this away, because we need here, this is actually very concrete. It's not an abstraction. So in this case, we are talking about cohesion. It's not really coupling. So we can see here simply, we can change that, okay, it would be an address, not an I address. So once again, very important, whenever you hear about coupling and about the dependency inversion principle, don't really try to be over obsessed and think that everywhere in your code where you are using properties of custom data types, that you should abstract them away. Because as said here in this case, this is a clear example of cohesion. We don't need to abstract anything, because that's an employee has an address, and that's it. But when we are in the program class here, the program class has to know things about something that's totally unrelated about what it is doing. So when we think about dependency inversion and cohesion and decoupling, we have to also think about the functionality. So when we say that higher level modules should not depend on lower level modules, yet that's totally true, but with the nuance that if the functionality itself of the module, like in this class, the employee class is a module, we can consider it as a module, and the address class is a module. So in this case, they belong together. So they don't need to belong together, and we have to decouple them and depend on abstractions when we are in a case that they are really, we have this class that needs to do something that's totally outside the scope of the class itself. So that's knowledge that this class doesn't actually need to know and care about. Cool. So now that we have that we get this out of the way, let's go to the next step, and let's see what actually this does. But before we go into this, I want to make the error go away, and I will remove this console logger that we have added previously, and I will take advantage of a feature that we have in Rider, which is the architecture and this show project diagram. And here it's important, not the IP violation, this is something else, so we don't really care about. What we care about is this app and this CWK logger. And we see that the app has a direct dependency, it depends directly on this CWK logger. And this is important because remember the question that we want to answer in this video is what are we actually inverting, and till the end of the video we'll watch this project diagram again and we'll see if anything has changed or not. Cool. So let's see how can we invert things, or how can we decouple this higher level module, which is the program class, from the lower level module, which in this class let's say is the logger manager class, and by the way the entire CWK logger assembly. Now of course what we can think about is, okay, that this app project or this program.cs class actually looks at this and says, you know what, I don't really care about all this stuff. That really doesn't concern me at all. What's the logger manager? What's the default log formatter? What's an exception log formatter? I don't really care about that. So what I will do here is I will create an interface and say, okay, I will say this is an iLogger. And I, as a program, as a client, as a consumer or of this interface, I just want two things. First of all, I want to have this void log message. And I just want to give the string that I want to log. And I just want to have here a void log exception. Of course, let's give it also like this, and that should actually do it right now. Okay, but of course this is an interface, so I should have chosen the interface, and right now we are good to go. So we say once again that this program class, this app assembly, says I don't really want to care about anything. I just want to know that I have an iLogger here, and whoever wants to implement something for that logger actually should do it like that. So what we can do here is I would just like to say here iLogger, let's call it logger, and for instance right now let's give it a null, and we have this logger here. Let's make it even nullable, and yeah, here I say that we have a log message. And I have here a log exception. And the only things that I want to actually do is just provide the string that I want to be logged. I don't really care about anything else. So this is right now what we do. Let's also here use this nullable check. And if it is not null, then we will simply log. And that's everything that this kind of like program class wants to know about, and it doesn't really care about anything else. Now to make things even clearer, let's go here to the dependencies, and we just want to delete the dependency to the CWK logger. We don't need that anymore. So we have defined here an interface, and then it's up to whoever wants to actually provide an implementation for this interface. I don't really care. If anybody provides an implementation and we log things, cool. If not, then well, that's it. We still do our own logic. Okay, now there is the one very important thing here, and once again I have read articles or watched videos that kind of like did this wrong, because in some of the videos that you will watch about dependency inversion, they do kind of like the same refactoring, but they would pull the iLogger interface in this CWK logger. Of course, they name their projects differently, but this is actually conceptually wrong. And the reason why this is wrong is because it's a standard principle that the interface is always defined or owned by the client being the consumer. So the layer or the class that actually wants to use that interface. So that is actually the holder and the owner of the interface. So if our program class is actually the owner of the interface, it can extend that our app project is the owner of the interface. So here we need to define the interface. We will not define the interface here in the CWK logger, because then the client, who or how would he know that, okay, I have this iLogger interface? Now, always the client provides the interface and the needs, and then it leaves to the implementators to actually implement things. And this is the reason, for instance, why usually you put the repository interfaces in the application layer if you follow clean architecture, and not in the domain layer. Because who uses the repository? It's the application layer, either that you use services or that you use handlers. You are using the data there. So you are using the data access in your application layer. That is the client. That is should be the owner of the interface. So this is very important principle. The iLogger interface comes where it is owned and is defined by a client. Okay, it's similar to, for instance, if I want to do some renovations in my house. Now, I would define and say exactly, hey, I need somebody that would kind of like, I don't know, redo my electricity circuits. I need somebody that would do maybe, I don't know, the heating, the plumbing in general. I would need somebody that would paint my wall. So I'm the client. I define that I really need these things. So I don't simply, I don't know, go on the street and then there comes somebody, hey, I can, I don't know, mow your lawn. No, but that's not what I need. So I'm the client. I'm in charge here. I define what I need. So that's exactly the same principle. Here we define exactly what we need. So we need a logger that just gives us the opportunity to log a message and to log an exception. We don't really care about anything else. Cool. So of course, if we have decided this, and if we have defined the interface, now we have this wonderful CWK logging library, and we want to implement, of course, this iLogger interface because we want to be used. So if we have created a library, then of course we want actually that's well, a client or somebody uses this library to actually do stuff, like in this case, logging. And that's our primarily focus in our CWK logger, to do logging. So that's what we actually do. Cool. So here we would need to do a little bit of refactoring, of course, because what we do here, and we'll start from the logger manager, we'll say, okay, this logger manager will need to implement the iLogger interface. Now, of course, the iLogger interface is in the other project, so we have to reference it. And of course, by referencing it and adding the interface, we also need to implement the missing members. And yeah, let's implement those missing members. So first of all, we have this one. So we'll take it from here, and it's the log message. It's the log message. Now, okay, here, of course, we would actually need to do some stuff, because if we log a message, then we as the logger manager know that we would have here a new default log formatter, and then format message. And of course, yeah, I have misspelled it, but yeah, that's not too bad. And for the exception, it actually something like this, but we would need to be careful that we choose the exception formatter. So it would be something like this, and here instead of this formatter, new exception log formatter. And okay, I got this totally wrong, so let's have message and message, and yeah, that should be it. Now what we can do is we can simply get rid of these methods, and yeah, right now we would be good to go. Cool. So we are now implementing this iLogger interface, which means that kind of like, yes, okay, we have provided an implementation for our client, or for whoever have or has defined this interface. And if we go right now to the tools and see here in architecture, and let's say show project diagram, we see that the dependency is inverted. So we are coming back to the question at the beginning, what are we inverting? Now, in this case, we have inverted the dependency. Previously, app depended on CWK logger, but now the CWK logger actually depends on the app part. So this, this is why it's called dependency inversion. Previously, we had app depending on CWK logger, like the higher level module was depending on a lower level module. Now, at least if we take a look at this architecture or at this diagram, we see that the lower level module actually depends on the higher level module. But don't let this architecture or this project diagram actually fool you, because the second part is that both of higher level modules and lower level modules should depend on abstractions. Now, if you just take a look at this project diagram and the dependencies, you say, hey, but we are still depending. Okay, we have inverted the dependency, but we are still depending here on this module. Okay, so if we think in terms of assembly, yes, in this case, we have kind of like this inversion and we are still depending. But if we take a deeper look here and try to understand here in this logger manager, what do we actually have? Well, in the logger manager, the only real dependency that we have on the app is the iLogger interface. So nothing else. We don't new up any objects that come from that project. We do not use any objects from that project as properties. So we are depending only on the abstraction. So we are depending only on the interface, and that's kind of like it. But there's still one question open. So what about this dependency injection stuff? Now we have seen that we have actually refactored this dependency. We have inverted the dependency, that CWK logger now actually depends only on the abstraction that we have defined here. And now comes, okay, but how do we really implement this when we want in a real program? Because right now we have an iLogger and this is set to null. So virtually if I run the application, even if it builds, it won't actually do anything and it would not log anything. Now, of course, in order for things to work, we need a mechanism through which we can actually get an instance of the logger manager in our program application. And to achieve this, we usually use what's the technique that's called dependency injection, and we have in ASP.NET Core by default and in .NET Core in general. And the dependency injection, what it actually does is really the technique that kind of like groups together the interface and the implementation. And whenever it sees, for instance, in the constructor of a certain class that it needs a service or an implementation for an interface that has been registered with the dependency injection container, it provides the instance automatically. So this means that if we would have here right now a dependency injection container, we could simply use that container and say, hey, require service iLogger, and it will then just give me that kind of logger manager that would be able to log. So this is dependency injection. There are, of course, other ways through which we could achieve this. One other very common pattern to achieve dependency inversion is called also service locator pattern, where you kind of like locate the services and then provide instances of them. But you could even, for instance, use regular factories in order to provide certain implementations for application that might actually need. Now, usually this type of inversion of control, or well, apps or frameworks that implement this principle, either dependency injection or service locator, they are usually called inversion of control containers or IOC containers. Inversion of control because they are helping us achieving this inversion of control or dependency inversion, like what we needed here. So instead of depending on the CWK logger, we just use an interface, and the CWK logger depends on the interface, and that's it. And it simply provides us a way that it actually does this inversion of control and provides us instances whenever we would need it. Now, for this video, I assume that it's kind of like enough, because that's really the main crux of what dependency inversion actually means. But I have plans right now because things are getting a little bit more complicated later on. And for a next video, we will try to actually implement our own IOC container, starting from exactly this example. And the idea of that IOC container is that you remember that kind of like rules that we said about interfaces, that they are owned by the client and defined by the client. This kind of like sometimes, or in this specific scenario where we are building an IOC containers, well, things should be a little bit nuanced, and we will see all the caveats and the headaches that we could have. And that will actually give us also a deeper understanding on dependency inversion, but it will also give us a deeper understanding about the dependency injection technique and the challenges that come with this dependency injection technique. This being said, thank you really very much for watching. If you enjoyed this video and you think it's useful, Don't forget to hit the thumbs up button and to share it with your peers, with your colleagues on your social networks, wherever you think that there might be somebody that would benefit from this video, and I would be grateful. If you have any questions or if you just want to get a discussion started, then feel free to hit the comment section. Don't be shy, and I really can't wait to actually jump into discussion and have a chat with you there. Yeah, this being said, once again, thank you very much for watching, and until the next time, I wish you the very best.